Hello, 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 and good afternoon. Welcome to Live Coding with Gerph. This is where we go and write some code to implement something or other. Today we are continuing with the project for Window Manager templates. This is something we started last week and didn't get very far on, but we've at least got opening files and closing files. So this week, I'm going to start adding in the implementation of the actual templates themselves. So we can start loading them, which shouldn't be too hard. It should be relatively simple, but we will see. I mean, all of this is just, we'll try and write things and see where we get to. So, in case you've not seen this before, we've got a GitHub repository that's got all the content in it. The aim is to implement a set of requirements that are listed in this page here. I'll also paste this link as well. This is the page for this particular subcomponent of the project. And as you can see, we have implemented opening and closing files. Woohoo! So we've got a number of things still to do, but we're going to be working our way through that. Hello to our viewers. We've got Dave and Sleepy Dev here today. So hopefully we'll have a few people. Had quite a few last time, so we'll see how we get on. So today we're going to start on trying to read a template from the template file. So if we go back to where we were, I'll just have a quick look. So this is the source code we have. Come on, move, make it bigger. I want to make your window bigger. Thank you very much. Right. So in the implementation here, we've got a templates module, which is actually the bits we're going to use to actually do the implementation of the reading. So far, we can open the file and we populate some information into a little dictionary here. Not a dictionary, sorry, an array. We create an array that's got all the entries for each of the templates, and then we can look them up. So that's the idea. We should be able to look up the templates that are present. Got some notes here that say that there's some deficiencies in this code. Fair enough, that's not a problem. We'll come back to those. It's not a big deal right now. And yeah, that's pretty much it. This is basically debug code. Since it's all debug code, I should probably put it into an if-def debug so it doesn't get compiled in and do nothing when we're not actually doing anything. I mean, it should actually be compiled out because this loop wouldn't do anything. But let's get rid of the code entirely. I actually can't remember whether the Norcroft compiler does that. So that's opening the file. This function here is closing the file. So the next thing we need to do is to be able to find a given template. So what I'm going to do is quickly jump over to the documentation, which I think is over here. Here we go. So we've handled header reading. That's been done. We've handled reading all the indexed entries and the terminator. The next bit is to find the data. So given a specific identifier, we need to be able to search for that identifier and find which bit of block of data we need to refer to. So we'll do a find, it calls it an identifier. Yeah, so we'll call it find identifier. And probably the easiest thing to do is to return, yeah, we want to return probably the size of the data. Actually, we want to return all the information about this, don't we? Yeah, so let's just return the index entry. Find it by index entry. Sounds like a good plan. So here we go. Templates find identifier. Find template block by its string identifier. Okay. And the parameters are, well, we want the open template that we're using. No, here we describe it. So OT points to the template we are operating, I say the template file we are operating on. So I should try and make a distinction between the template, which is the one entry, and the file, which is the whole thing. That's the plan here. Oh. If I start sneezing, I'm really sorry. I've been sneezing all week. It's been really quite but I apologise. I will try and mute things so you're not getting loud sneezes over the stream. And we want to find a template file. So don't describe it as the type there. This is the name or ID. Identifier we are finding. Now I don't remember whether this should be control terminated or not, so I'm going to quickly see if I can find that. Oh, template's that one. That's that one, isn't it? No, stop that. I didn't mean that to click that button. Go to site. Yeah, that's the one I wanted. So copy, paste. So I just copied this out of the chat because I forgot to load it up. Oh, that didn't work. Where did I get? Sorry about that. That's what I meant. So there we go. That's actually there. And load template. The identity must be 12 bytes, word aligned. Well, that's very, very tacky. That's incredibly tacky. Doesn't actually say whether it's terminated either. I'm going to assume that it is control terminated. Because that's the superset of 0 terminated. And it should work. So we should return index to the template to use, or -1 if invalid. Okay, so int templates find identifier, open templates OT, and some extra lines there. That's just frustrating me. I like to have a bit of space at the bottom, so I've actually got some nice to work with. And then the identifier to look for. So that's a in our control string. We define a control string type. There we go. So it'll describe what it actually is. Right. So we just want to find this. Of course, I don't remember how to look for it. So it's in open template, the entries, and then in each of the entries we check the identifier here, which is actually already 0 terminated in this copy. So let's go through this. See, it doesn't actually even say in the documentation that it is even terminated. It just says it's 12 bytes word aligned. It's very, very lazy, really. Well, it can always be changed. We can always change how this works. It's not a big deal. So let's go and look for it. So we want a little loop that goes and looks through, oh no, not all the entries. No, I want to find the template. So actually, how does this work? Int I, here we go. For I equals 0, I is less than OT to n entries. I++, and the brackets around that as well. Right, so this will go through all of the entries in the index. And then we want to check the index entries. What are the index entries called? And it's that string, in fact, there. That string there is the thing that I want to look at. So control, it's a 0, yeah, I can call it a control string, why not? Probably didn't need to 0 terminate these, but it doesn't matter. Index ID, actually, indexed entry. Let's do that. Don't think I need the ampersand on that, do I? In fact, that's not a control string. That's a oh, what was it called? I've already forgotten what it's called. It's a template index entry. Right, there we go. iEntry to identifier, comma CS. If CS stra oh, it's not CS, it's a cuttle, isn't it? Sorry, we call them cuttles because then it distinguishes it from a control or space terminated string. If that's 0, left an eye in that because the eye should be there. Then we found it, and we can return the identifier. Apparently I didn't indent that properly. Weird. And then if we get to the end, we didn't find it. All right. Well, that's pretty easy, isn't it? Yeah. All right. So that finds us the identifier. That's the first stage of looking through these. The next stage is going to be to find the is to load the data. I didn't find the data. Actually, we want to do and like, read an identifier, don't we? So read template. Read a template into a user buffer. Buff points to the buffer to write into. Root is the template file we're operating on, and we want ID pointing to the template, no, index of the template we're reading. Buffer is the buffer to write into, index is the template to use. Or -1 if you're bad. No, we're not going to do that. Returns. Now, if we have a look at the load template code here, there's a lot of things. There's the required size of the buffer, remaining workspace, what the actual name was, and the next entry. And I'm intending that we'll use some buffer handles to do this. There's also passing in a font array reference as well. So I think, yeah, I don't think we really need that one just yet. Just yet. We'll add that later because implementing fonts is going to come a little bit later. Yeah, okay. So we're going to return, I don't know what yet. I'm going to say none because I think we'll just work out what we need later. But what I want to return here is, so what I want to pass in is some buffer handling. I have already implemented some buffer handling, and did we use it in, I can't remember whether we used it in the system variable handling we did last time. I don't think we did. I think it was all simple enough that we didn't need to. So I'm going to quickly find it. So if we just have a quick look in it was in resourcefs, which I don't have here. So it's in modules, resource sources, resourcefs 2. In fact, that's what we want. So what I'll do is I'll just pop up the editor for this. So here we are. So this is ResourceFS 2. This is a re-implementation of ResourceFS. And one of the things we've got in there is this thing called buffer data. Actually, let's go to the header. It's probably a bit easier. So buffer data, and we describe it here, is a way of handling RISCOS style buffers. So in RISCOS style buffers, you take in a buffer and a length, and then you keep writing multiple chunks into there. And at the end of the operation, you say, well, I couldn't fit it all. There was this much space I need. And this buffer data module library handles all of that for you. So if it can't write the data, it'll just remember how much space it needed. It also has a concept of completed entries. So in the case of OSGBPB, which is used for enumerating files on disk, you say, I want to have 20 files in this block. The block is 2K long, populate it for me. And so it'll try and write as many as it can, but it'll only tell you I've finished this number. So if it didn't complete a whole entry, it won't do that, but it'll tell you I needed this much more room. That's the idea anyway. So that's what it can do. We're not going to use all of that functionality, but this library is it's the same structure as what I use in my Python code. So it'll make it very similar, if I've used it in there, to how that's written. It's not a particularly complicated one, but yeah, we'll take a copy of this. So the easiest thing to do is just create some files here. New file, buffer data. Realistically, this should be copied over as a library and implemented that way, but right now it's fine to do it this way. I'm not going to worry about it. I put this in the wrong place because that's the header file. Buffer data. There we go. So move that from there into here. There we go. And then get the C file as well, the buffer data. Copy that and paste that into the C file. Right, there we go. So we don't need that anymore. Yeah, that's that library. I now need to update the make file so that it uses it. The make file for the test code. Here we are. Test code. O.buffer data. There we are. Oops. Buffer data. Cool. So we go back to here, back to the buffer data function. Not buffer data function, we want it in, look at the template, sorry. And we're going to want to pass in, oh, I can't remember what the structure was called. It's called buffer data. Good. Buffer data T. There we are. Here we are. And we'll call that a buff. All right. I've just changed the wrong function, haven't I? No, I haven't, because this is one that I haven't updated the content to. This is called read template. But there are two buffers. If we pop back over here, you'll see that there is a user buffer and then there is a workspace buffer. And bizarrely, it uses a pointer following the workspace buffer. It's a little bit odd like that. It doesn't say size, but that's just fine as well. Excuse me. So there is the window. So we'll call this WinBuff, I think. And then we've got IndBuff for indirected data. What should I call them? BuffWin and BuffInd. Does that look better? Makes it clearer that they're both buffs. Right, there we go. And each of those buffers will have its size updated, so we don't need to return the sizes that are needed there. So that will make things a little easier. Okay. Ah, errors is potentially something we could do, isn't it? Yeah, errors are probably a good thing to return here, but let's work out what the error is going to be first. So firstly, we have the index to read. We have the window buffer, and we have the buffer data buff end. Okay, right. So first thing we need to do is to seek to the entry and then read the data into the buffer. So where is... Oh, no, I don't want to go there, do I? I want to just seek, don't I? Do we have a template seek? Template seek, there we go. Offset and how. Right, fair enough. Not really thinking about what I'm doing here. Template seek. So what we want to do is we want to start out with the offset OT index. No, we need to go OT to entries bracket I bracket dot. Is it offset? I think it's offset. Let me just check. In the templates, data offset, data size, and then data type. So there's data offset, and we want to do a seek set, sorry, seek to that position, and then we want to, I don't know what the size is as well. That's int size equals, oh, not that, this one. Thank you. Data size. Oh, excuse me. Oh, I'm very sorry. We seek that size, and then we want to read the initial block of data. So the initial amount of data that we've got in there, if we have a look in the template format here, it just says 88 bytes of window definition as described in create window. So what we really want is that data that's already been defined. Unfortunately, we've already got that. We've got that in oslib. So what I'm going to do is I'm not going to use the oslib library itself. I'm going to actually pull it out of the data that we created. So if you remember last week, over here we had the oslib parser stuff, which had some generated code for C module templates, and one of those is the window manager. The window manager called Wimp. There we go. And that has got in it some header files that describe the types. So if we have a quick look at the types in there, in fact we could probably copy the whole, no, we don't want the whole lot, we just want the types that are related to the windows. So let's just have a look. I mean, these will have the same types as everything else, so it's not going to be too bad. Types. There we are. Right. So we're going to have a look down here for template. Oh, look, template, there's a constant there, that's quite handy. Ooh, some error numbers, good. We will look at that later. Error handling we can put in a little bit. Okay, so I don't want those, I actually want the window itself. What does open window do? So open window, there must be some definition for that. Okay, open underscore window. I'm not sure, surely it must be in here. I'm watching. That's a message, some colors. Messages. Icon data. Yeah, icon data is something we're going to need. We're going to need the icon data, so let's copy that. Create a file in here called types. Yeah, we'll just call it types because then it matches up with the other one. So there we go. We've got that, not that file, this file. Thank you. We've also got, oh, is it using the icon flags? No, it isn't. That's the icon data. Menu, menu, menu. Messages. Here's an icon. An icon is defined as being some icon flags and some icon data. That's fair enough, so we'll copy that over as well into here. We're going to need some OSBox and some icon data. That's fine. We'll copy that over in a minute. Messages. Lots of messages. Wimp window. This is the one we want. So we're going to want the window flags. Some colors here. Icon data. There we are. That's all of those bits. I don't want all of those. We haven't defined, okay, we haven't defined a lot of these types. So let's see what we can grab, shall we? We need some, oh, there's the icon name limit. That's interesting. So we can grab that as well. Icon name limit. There we go, grab that. And whilst we're at it, we'll also grab this one here for the template name limit, because that's bound to be useful. The icon name limit was there. What else do we need in here? We need some, oh, not this one, sorry, I'm in the wrong file. This is the file I want. I want the OSBox and icon flags. Now I think icon flags is just here. There we are. And OSBox. Not that one, not that one. Not the definition. OSBox semicolon. There we are. OSBox is one of those. Okay. Do. Not that file, this file. No, not that file. I've lost my files. I've lost which one I want. So I'll look at this one. This is the one. Oh, I also need a SpriteOp ID and a SpriteOp area. Yeah, well, we'll define that then. Grab that out of template types, which is this one here. SpriteOp area. There's that one, and the SpriteOp ID is right next to it. Oh, that was handy. They're right next to where I was. Maybe if I'd paid attention, I'd have noticed that. Let's put icon flags closer to the icon data and bits. Okay. Next thing, we've got those. We've got the indicators. We didn't define that. Icon flags we've got. Icon data we've got. Structure, yep, that defines that. Now, a window is defined as being OSBox. Window flags and a color. So I think we can get both of those together. Window flags. There's a window flags. Color's not right next to it. No big deal. Oh, I'd already grabbed window flags. That was dumb. So Wimp color. So you might be saying, wouldn't it be easier just to include the oslib files for this? Yeah, probably would have been. But I want to make this largely standalone so that it can't be handled any differently. It can be used without having to access all of the oslib headers, just for ease. In the future, that could change. But right now, let's not worry about that. So Wimp window extra flags. Okay. Find extra flags. That one there. Okay. There you go, you got some extra flags in there. That's an 8-byte type. SpriteOp area we've got, icon data we've got, and an icon we've got. Although I don't actually want it in this because I just want this to be the window header. Do I use the window header? Because then it's different from the type that I use in. It'd be different to the type that's in oslib. I don't want to make it different. I'll do a little definition here and do define Wimp window header size is size of Wimp window. Is it Wimp window? Just Wimp window. Yeah, just a Wimp window. Minus size of Wimp icon. So the header is just the thing without the one icon that we've got on the end of it. In this earlier version of the compiler, you can't define a structure that has 0 length, or is undefined, so that it's got no extra icons on it, or an undefined number of icons or whatever. So we have to do it that way. Right. I think this file is now complete. I don't think I've missed anything. So I need to include studint.h because we're using the int32s and the like. And we need to define this, give this a description. So this is types, oslib types used by the window load. So in theory, template load. If we do integrate this into the window manager, all of these just vanish and we use the ones that are in the window manager itself. If the code gets integrated into there, that's just fine. The date today is, I got the date wrong last month, last session. I thought it was the 5th of November. Very, very confused. 09 of 2025. And this is a header, so if nedef types h, define types h. There we go. Okay. So that gets us, I think, all of the parts that we need for this. We probably just need to include it. So let's include that file. Include types.h. Oh, I also need to include the buffer data, don't I? So because we're going to use that. How about I just try and compile this and see that it's going to compile? That sounds like a good plan, doesn't it? Let's implement this. And we've already made a note that error returns are an issue as well. Okay. Whilst I remember, I will copy the prototypes into the header file as well. Okay, here's a prototype for that, and here's a prototype for that, just like this. Okay, and we'll update those as time goes on. Right, let's see if it builds. In fact, let's see if it builds by using the build system in here, in the editor. No is the simple answer. Oh, I haven't included buffer data in this header, that's why. That's fine. Buffer data.h in there, and then we'll build it again, and we'll see whether that fixes a bunch of things. Oh, dear me. Simple typos. Make me look dumb. Well, more dumb there. Oh, I missed one. A Wimp window W. A Wimp W, which is just a opaque handle. So Wimp W. Yeah, it's just a void point. Oh no. Oh no, it's not. Oh, that's bad. Because it's only a void star on 32-bit systems. So that's going to be interesting. In fact, same goes for these. These are not going to be char stars. because for now they're going to end up being just bare pointers that aren't char stars. Oh dear, this is going to be fun, isn't it? And actually that void star for, oh dear. So all of these structures are going to change in type in the future, but right now I've got to make it 32-bit safe. So what David suggested last time was using an ADRA type in here. So if I look in templates, I think, did we define an ADRA type? No, maybe it wasn't in here. Maybe it was in the system variables code. Okay. Let's define it in here. An ADRA-T. Oh no, wrong way around, sorry. A uint32 that is an ADRA-T. (32-bit) address pointer. And then we'll just have to replace these. What I should do is use my magic thing that I pinched from many places for structure sizes. So let's stick this in here. Could have copied the comment as well. Right. So this is for a window. Wimp window. So the size of a Wimp window should be 88 plus the size of an icon. And we should also have a check for an icon. And this should be, actually I've forgotten how big it is. I'm sorry, I think it's 32 bytes. In fact, I'm pretty certain it's 32 bytes. And the reason I'm certain is because if I look back over here at the definition, it says that the number of icons times 32. So yeah, I'm pretty sure it's that. Okay. It is icon, isn't it? A Wimp icon, there we go, yeah. Right. And a Wimp W must be an ADRA 32. And this has also got to be an ADRA 32. So anytime we use an ADRA 32, we've got to go and cast it to the actual type. That's what we're going to have to do with that. It's just live. Oh, and I've forgotten to specify it here. Sprite area pointer. Well, actually, it's not. That's going to be just an ADRA 32 area, which strictly means that I don't need this definition here at all either. Okay. And then these ones here for this side of it also need an ADRA 32T. Any others in here? I think we're all good now. Oh no, there's another one. Another pointer that needs to become an ADRA 32T. Okay. Now let's try and build that. Expected bracket before. Oh, I forgot me trailing brackets. That's all. Build that. Nope, I did need an ampersand on that. control strcump, and because CS is not correct either. iEntry may be used before being set. I think that's just because it was not. Yep, that function is not defined apparently. And then, okay, so we'll have to write that, I suppose. Yeah, control strcump isn't present. So let's write one. Compare two control terminated strings. C1 first string, C2 that second string, and we return 0 if same, or -1, or negative if less, or positive if more. Simple. C1 string to C2. Yeah, we don't need that. We are going to need to do some work, but we don't want to increment it whilst the character is greater than or equal to 0. Ooh, not equal to. Greater than. Oh no, greater than equal was right. Sorry, I'm confused. Right. Actually, this is just a this should be a while loop. Hold on. Right. Diff equals star C1 minus star C2. If actually no. I'm going to call those C string. C. I'm going to call them control 1 and control 2. I should keep the same consistent naming system. Right, there we go. Control 1, control 2, except C1 equals star 1, C2 equals star 2. I'm not sure the differences, but if C1 is less than a space, make it a null character and repeat for C2. There we go. Diff equals that. If diff is 0, we are all good. Oops, no, that should be C1 minus C2. If C1 is 0, is a null, we're finished and they are the same. Otherwise, actually that is the only case, isn't it? Otherwise we continue. Control 1 plus plus, control 2 plus plus, and we continue. So wouldn't it be better then to do if it's not 0? Because then this all becomes the tail end of the loop. If it's not 0, oh, we just return the diff, don't we? Yeah. And that might as well be break there, so we actually have a normal exit through the end of the routine. Looks okay. Looks like I've misnamed that. Yeah, that looks all right to me. Yeah, it looks okay. Again, these can move into a library at some point. Oops, didn't mean that. So that we can then use them everywhere, and that will make it much more what's the word, reusable, and we should be more confident in these libraries. But I haven't written too many of these yet, so I haven't needed to. Or maybe I have and I need to just haven't realized it. Yeah, we'll see. So if we now build the code again, implicit cast a pointer and non-equal pointer. Is my identifier not a control string? Oh, it's not actually a control string, is it? I've zero terminated it now. Let me do that. Ooh, no, that's not what it's complaining about. It's complaining about the fact that I've made that a pointer to it. And now it's complaining that I've changed the prototype. The external interface and the internal interface are different, which would be bad. So this needs to be replaced with that. Build it again. Oh dear. Inventing I. Really? Oh, no, yeah, really. Index. Again, index, and then we compile. Woohoo! Okay, that's not too bad. It means that we've now got the basics of being able to load this. So what we want to be able to do is to load that entire window definition into memory, into the buffer that's been given, which we can do relatively easily. Probably the best thing for us to do actually is to, I wonder, I'm just wondering, because if I, I need to actually have this in memory, even if the buffer isn't present, in order to operate on it. So I am going to need to have a local copy, Wimp window here. And then we can read that into there. So if we do templates read from OT into win of size Wimp window header. Is that right? Was that what header size was it called? I can't. I've already forgotten. Wimp window header size. I think that's what I said. Yeah, it's nice when the names you come up with are actually the names that you would think to use if you were trying to use them. Naming things is hard. Right. So we want to read the header size, but we also want to know this returns the amount of data we read. So read. Excuse me. If read is not equal to Wimp window header size, return something or other. Interesting. We've got to return an error. Template error. EOF. So end of file. There is nothing else we can do about that because the file is short. or is corrupted or something like that. So let's just create some definitions in here for different template errors. And we can create this as an enum. Type def enum template error te, or should I call it template error? I'm just going to do it this way because there we are. Right. And that means that we've now got a return type. Template error code. There we go. Right, so there's my template error. If we failed that, we don't need to close anything down. We've not done anything we need to worry about just yet. We are implementing it, it's okay. Error returns are now being thought about. Oh, yeah, of course. No error is also a... Yeah, okay is probably a fair thing. Right. So now we've read that header into memory, so we're going to be able to operate on it, which is good. And we want to copy all the entries across to the user's buffer. Many of these entries are going to be just plain copy over, so we're not going to care about them, but some of them we're going to need to manipulate. So we'll start out with the first part of this, which is going to be copying whatever we can. So let's have a look at the type for this. This is the data we're interested in. Yeah. So we're going to want to copy all of these across, and we're going to write them to buff win. So we're copying out of win into buff win. And I need to remember how to use the buffer functions. So what do? I want to write a word. Okay, write some bytes. That's an arbitrary amount of data. Good. So arbitrary amount of data is one of the ones we're going to use, and write a word is also something we're going to use. So we'll start out with those, and then we'll work our way through it. So first thing to do is we want to copy this box. Buffer data. I've forgotten already. Write bytes. There we go. Write bytes for buff win of size. Sorry, I've forgotten already. Come on. From there to of this length. Okay, so from win.visible of size win.visible, because then I don't have to know the types of them, which is quite handy. Right, X scroll and Y scroll, we're going to want to copy those as well. And I think so I can probably do this as, yeah. I'll do it this way. This is not going to be as efficient as you might want it to be, but I want it to be clear. Somebody can make it more efficient, that is their prerogative later, but I want to just get it working. X scroll and Y scroll, that's those done. Now, the next point, I think we always write this to be top of stack, but I can't remember what we do. So what I'm going to do is I'm going to jump into Riscos Pyromaniac and have a look at its code. So if we have a look in /, oh, I had problems finding this last time, didn't I? It's the template handling. So Pyromaniac projects row Pyromaniac Riscos. PyMods core Wimp. Probably in templates, I think. Templates.py. Aha, here we are. Right. So this is the open code that we looked at previously. Doop, 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 doop. Lots of operations on this. This is very similar to what we've implemented. You see, we've also implemented wildcard handling here, so I'm going to need to do that in the future. I'll worry about that later. Right now we're in the loading code. The original implementation reads the whole data into the user block and then distributes the data to the workspace. We're not doing that. Okay, we're going to do it slightly differently. These are going to be different implementations. There you go. We read all the data into memory and then we go and start operating on it. We also read each of the icons as well. That's interesting. That's kind of interesting. Yeah, interesting way of doing it. Okay, yeah, I see. So basically what we're doing is we're returning back a set of parameters. This is a set of parameters that we pass through to say this is where we're up to. I may need to do it the same way. But for now, let's just work through the problem we've currently got, which is handling. Oh, I see. Yeah, he's fixing it. He's me. It's me doing this. Yeah, I don't actually write the behind handle to be -1. Interesting. I just assume that it's going to be there. That's probably not. Yeah, I'm going to work through it. Dave says that Gerph is clever. Says Gerph. Sometimes I surprise myself by being like reasonably sensible, and here I've not updated the next pointer. Oh, dear me. Should the below window be forced to -1? I think it should. So that's what I'm going to do. So I'm implementing basically this section of code at the moment, but I'm doing it a little bit more explicitly. And then we'll do the fix of icon code, because icons need special handling, lots of special handling. Okay, let's give this a whirl, shall we? Right. So I'm going to say this should be written as -1, regardless. Not window, so like word. Always force window to top, because there's nothing else you can do. You don't know the handles of any other window, so there's nothing else you can do. And by leaving it as any other value, you could actually be causing a problem for the system. I mean, maybe create window won't allow it, but this is, yeah, this is probably safer. So that's that one done. Now the window flags. Yeah, let's just write the window flags. That's just a word as well. Window flags. Next is all of these colors. So we can use the same thing we did here. We're going to write the bytes for title foreground, size of title FG times 1, 2, 3, 4, 5, 6, 7 plus the size of win extra flags. There we go, so that's all those handled. And then we've got another bounding box, which is one of these. some icon flags and some work area flags, both of which are icon flags. So we can do that in a similar way to this one. Title flags. Title flags times 2. I'll actually label this the colors. And this one is title plus work area flags. Okay. I mean, strictly, I could have gone and copied the entire block into the workspace and then gone and said, I'll update some of them to be different. That might actually have been better, but we'll go with this. Right, sprite area. Now, this is an interesting one because the sprite area, again, you can't know what this is going to be. Should I be forcing sprite area to be the Wimp sprite pool? Not sure. And then we've got min and xmin and ymin. Those are shorts. Again, we can do one of these. Xmin min times 2. I did say, oh, that was clever in the code that's there. So I thought it was clever, but I'm pretty sure that was like the 3rd or 4th iteration of how I'd implemented it, because I found that previously I'd done it not as well and I needed to do things differently. I'm pretty sure there was originally I was returning a tuple back from it, and the tuple just got longer and longer and longer, and it was like, no, this is getting silly. So that's probably why I did it that way. And then we've got the title data. Now this is going to need some special handling. So title data, let's just leave it bare for now. And then we want to handle every single icon that we've got present. Excuse me. Interesting, yes. I'm just going to change this so we use the offset here, because we're going to need to jump around the file to be able to read the I've forgotten what it's called, the icon indirected data. Dave says he dived into the world of templates when he amended CC res, and it wasn't fun due to the quality of that code base. I suspect that this probably wouldn't feel very comfortable either if you were to come to it in the future. But yeah, CC res is, I don't know what it stands for actually, but it's intended for manipulating template files and producing, I think it's textual form versions of them. It's actually a really useful tool. I could really do with one for Linux. I did try building it, but I couldn't seem to get it to work, get it to build for Linux, and I don't know why. Probably, as Dave says, because it wasn't a great code base to work with. But yeah, does res files too? Yeah, because that's the other thing that would be really useful. Yeah, because of the amount of cross-platform work I do, those sort of tools are exceptionally useful because I don't want to be working with binary file formats. But I haven't got them, and yeah, I did mean to put them into my build environment, but I haven't got around to it. Ugh, so many things I need to get around to. Hey ho. Yeah, anyway, so I will, yeah, I should have a look at that. So many things I want to do. I was in the middle of trying to work out how to do this, wasn't I? So this was the offsets, yeah. So the reason I'm moving around the offsets here is because we're going to want to jump around the file. And if we are, then we're going to need to want to jump back again to where we were. So here, if we do offset plus equals offset, this will now point to the icon offset. What we're going to want to do here is icon num. So comment that out temporarily. For icon num equals 0, icon num is less than win.icon count. There we go. Yeah, that's right. Icon num plus plus. Ooh, and handily, our Wimp window definition here actually has a definition of an icon in it. So I can actually do Wimp icon star, this is the icon, is win to icon bracket 0. That'll give us the data we're going to write in. So I don't need to create any more icons. That's good. Right. So first thing I want to do is to seek to that position. And I'm going to do a seek anyway because we may have seeked elsewhere, as we did our forgotten what it's called, indirected data. So first we seek to the right place, then we read in some data. Again, same call as this. Read in some data of size of Wimp icon. And that is into icon. If we didn't read that, we didn't read it. If we didn't read all of the data, return E off. We ran out of data in the file, that's broken. All right, so we've now read that file, that icon. We can now, ooh, hang on, I've missed something. So I'm assuming that we're going to handle the title data icon here as one block. Now we'll handle another block here for each of the icons. But we do want to write out the number of icons. Win.icon count. There we go. Handle the icon data. Okay, and then we're done. That is essentially all I need to do. So what we're going to do is we're going to have a routine which is write out icon data. A static function, templates, write icon. And we're going to pass into it the open template. No, we need to actually find these, don't we? So it's the same data as this. Index, don't need that. Wimp icon star. The icon we're going to write out. There we go. Templates. Write icon. Write an icon into the user's buffer. The OT, the template here. actually, all of these can just be copied as well. And what else do I need? I think that's it, isn't it, for now? For now, that's all I'm going to need. So this is going to write the icon, implement properly. But all we're going to do is go, oops, write bytes to the window buffer from icon of size of icon. There we go. Doesn't do anything else. Oh, and we want to return an error handle in the same way. So template error t. Because we might have an error whilst handling this. Return, oh, not a pointer to it, no. Not a pointer, silly boy. T, okay. Yeah. All right, so handle the icon data, which is going to be calling that function. So both of these are going to be, oh, I forgot what I called it. Templates write data, write icon, there we go. Templates write icon, OT, buff win, buff ind, oh, and the icon as well. And the icon for this one is the title data, so it's win, not wub. Oh, wub, a wub, a wub. Title data. And the reason that this is the same is because a title on the window is actually just the same data. Oh, except it's not an icon, it's not just an icon data. Oh, this is pain. Yes, of course. Oh. And if I'd looked at the templates pie, the fix up function, I'd have noticed that, hang on, where's the fix up template, fix up icon? I've lost the fix up icon. Here we go. We pass in the icon flags and the icon data, and the bits at the beginning are all written out separately. Yeah, okay. Let's go back to that. Let's go back to that. So this should be right icon data. Make it clear that what we're doing, and this becomes icon data. Yeah, that's fine. Icon data points to the icons data. Oh, we also need the flags as well, and the flags. I said I needed those, didn't I? So I need a Wimp. Is it icon flags? I think it was icon flags. Flags. There we go. Right. Yeah, there we are. And we return template error. Code. And now it's icon data. Let's be clear that it's icon flags. Yeah, all right. See, this is why having the previous implementation makes it a little bit easier, because I would have been having to find these things out again and going, oh, this is wrong. I've also put these in the wrong place. This one goes on the end, and we also want the icon flags, which is in Wimp win.title flags. I think it's title flags. Yeah, title flags is here, this bit. So there we go, title flags and the title data. And then we do the same thing here, but I need to write out each individual part. So first, let me find the buffer structure, the icon structure. So we've got icon and then icon flags. Here we are. So I need to write those out first, then write out the icon data. Okay, nice and easy. Copy that so I know what I'm writing. I think this should come So this is an OS box. In fact, it's this one here, the extent one. So I can change it even less. Icon to extent. Oh, it probably should be ampersand, shouldn't it? I want to get the address of it, yeah. And then we want an icon flags, which is the same as this title flags, but not two of them. Actually, it's just a word at that point, isn't it? So I may as well just write it as a word. I mean, this might... No, it won't change. That's fine. Sorry, what was it just called? I've already forgotten. Flags. All right. Flags. There we are. Okay. And then the icon data follows on. And that's an exactly equivalent routine to this one here. Templates write icon data. Window, indirection, title flags. No, it's icon to flags, and then the icon data is, oh, I forgot what it's called already. Data, icon to data. There we go. So that is it going to build? Not really. Type disagreements. Now that's because I've changed the prototype. So let's just fix that up in the header. In the header down here. All of this, just replace it. There we go. Nicely done. Oh, because we've got template error. Oh, and of course template error is now in here, so we've got that defined as well. Good. Type disagreement. Inventing templates write icon data. Isn't that what I just called it up here? No, it isn't. DATA. There we go. Now it's called the same thing. Mr. Semicolon. All right, we'll put a semicolon in. I'm still thinking in Python. Illegal types. Oh, because that's actually it's an inline structure. There we go on the stack. Size declared but not used. Maybe I don't need it. I'm not sure. And then icon may be used before being set. Ooh. Oh, that's because it didn't know it there. Let's rebuild again and see if we get any problems. Has no icon field. Is it because it's called icons? Whee! Okay, that builds. So we now have a simple routine that will go and try reading out a structure. I mean, it's not going to do very well because, well, it's not particularly wonderful, this, but we have got a structure and it's going to look sort of right. So we need to test this somehow. At the very least, we need to test that it doesn't crash. So let's try doing that. Where's my test code? Test code's in here in main, isn't it? Right. We open the file and then we close it. So let's go and try giving this a read template call. Template error TR, because then I can distinguish it from a OS error. Read template. Template we're reading from is OT, and then we've got to define what the buffers are. So we need some buffers. So this is buffer data t star buff win, and we need a buffer data t buff ind. Buff win equals buffer data. I don't know how to create one. How do we think we create one? We call create maybe? No, we call init apparently. Oh, and we actually have it as a structure in memory. Oh, right, okay, so we can read stuff, fair enough. So we'll just actually take those off there. Buffer data init, buff win, sorry, ampersand buff win. And then where the data lives and its length. Well, we're going to just give it a large buffer here. So buffer window. We'll call it window, we might as well. And we'll give it 1024 bytes. So we'll go ampersand window and size of window. And we want some indirected data as well. And that's going to be 1K as well. Oh, we don't assign it to anything because it's just a call to initialize it. Size of indirect. So normally these will be passed in by the user. So we're just dummying them here. So we've got something that we can use. And we've got read template using buff win and buff ind. If we have an error, oh, we need to give it a name as well. What template name to use? I can't remember. I'm just going to call it test because I can't know what the. Does that come? Where do we actually pass it? Not buffer data, I want templates. We pass it an index, don't we? Oh, we'll just read index 0 then. There we go. We don't need to know what the name is. We'll just read the index there. There we are. Error reading template. This is the error number. Right. And we can print some parameters. Buff win. Window buffer space used. How do I get the space used? Not that function. Address failed. Can read whether we failed or not. Number of records, remaining space, space required. That's good. Indirect buffer space needed is int. Okay, so that'll tell us some useful things about how it actually worked or not. I've still got a warning on that. Ah, it's gone away. Good. Build that. Ooh, implicit cast of proof. Is that because I did that? Should it just be that? I'm confused. Which one is wrong? It's really frustrating. It doesn't actually tell me which parameter it is. Oh, I wonder if I can build it as 64-bit. Then I can get the GCC errors. Come on. Thank you. Argument 2 makes integer from pointer. But it hasn't complained about those ones. Well, that's nice. It's integer from pointer without something or other. Without a cast. Really? What? Hang on. Have I misused the template? Read to. Oh, yes, I misused it. I put the number in the wrong place. So that one should go there. What have I done? Stop it. Paste was what I meant. Then build. Oh, that's typical. It builds just fine in there. Maybe I should do W all to turn on all the warnings for GCC. Maybe. For now, let's see if we can work out what's wrong with this. So this is a sounds bracket 0, that's what it should be. Address of the first byte. Oh, I'm still building it for 64-bit. Build it for 32-bit. Right. That's a char star, is what it's getting there. And that is a buffer data star. So have a look in here, init. A uint 8 star. Oh, well, all right, we'll make it a uint 8 then. I don't really care. I mean, strictly that's correct, because a char could be any sort of size. So this is actually correct. Build. It is a genuine warning. Right, okay. Let us have a see what we can do. What we've done, rather. Sorry, let's risk off. No, I'm in the wrong window. I want the templates one. Pyro dev. I want to just run it, don't I? Command. Oh, common. Load up all the modules, and then yeah, that command's there. That's the one I want. Doop, doop, doop. Whoa, would you look at that? So, window buffer space needed, 376 bytes. Indirected space needed 0, because I haven't actually provided any yet. But it has now read the file, and it may have written something out into memory. It probably has written something out into memory. Ooh, if it's written something out into memory, window buffer %p, window, and same goes here for the indirect buffer. Build that. Thank you. And then run it, and then run GOS at the end. So now, oh, yeah, I didn't update that indirect. That's fine. I don't. There's nothing. We know there's nothing in there. But if we do a memory, how do you top memory? My debugger's a bit. Yeah. Is it memory W to print words? I don't know. I don't know how to use debugger anymore. At BD F8. No. Oh, it's written zeros. Oh. Oh, that's a bug. It spotted the B at the beginning and gone, oh, you meant to print it in bytes. Oh, I don't like finding bugs in my code. Well, I do, because then it means I've found bugs, but... So there we go. What it looks like here is we've got some data being written into here. We've got that looks like a... so probably this bit through to here looks like a... oh, maybe it's not. That's definitely an OS box. FFFC00. That's interesting. I don't know what that would be. Ooh, look, all of these values look like the same thing. I think I failed to read more data each time. I have a feeling, did I just call seek and forgot to call read? Oh no, I did call read. That's interesting. But every single one's coming out the same. How odd. That is very strange, because that definitely looks like some colours. This looks like more colours or something. Yeah, possibly colours, I can't tell. Not sure what those are. So yeah, there's definitely some interesting things about this that are not quite right, but we have got something that's kind of working. I mean, kind of working in the sense it's populated some data. Not very usefully. We just plus 10 376 it wrote. Yeah, it's written that same data over and over again. So something's a bit broken there. Oh, we seek to the offset and then we never move on. So we always seek back to the same place. Seek plus equals red. There we go. That's what we should have done. Now if I build it and then rerun this. Yeah, there we go. Exit that, rerun. And we do a disassemble of a different address because it's moved slightly. BDFO. Oh, they look different. That looks much better, doesn't it? Oh, feel a little bit relieved about that. Yeah, this looks like a set of icon flags. Color 7, color 1, so that's grey. The first grey, and that's black. I think 7's black. And then 3 is bit 8, which means indirected. Bit 9, I don't know. Bit 4, I thought that was a border around it. Bit 1, bit 0, sorry, is this is text. So Dave says the other thing that was biting him in CC-Res, it wasn't coping with the full 12 character template names, since they're not I don't handle that either. I have implemented it so it doesn't handle that. So I'm going to need to handle that properly. Okay, thank you for that. I had not appreciated that. Let's put a note in here. Yeah, this is wrong. Fix me. Identifiers should be allowed to be 12 characters long, unterminated. Right, so that's going to be something we're going to need to handle in here. Thank you, Dave. I will need to get a template that's actually got one of those. I mean, it just means renaming a template, but we'll create one so we can actually check that that does still work. Cool. Thank you. I always nod down to that side, which is where the chat lives for me. Might be easier to check. I looked that way, but yeah, it doesn't matter. Right. Anyway, where are we up to? So we've got to the point where we can read the data, but it's not valid. Let's checkpoint this, and that's where he lives, off camera. I probably should be off camera as well. You'll notice I've actually got the colour balance a lot better this time. I actually spent a little time trying to tweak the contrast, saturation and gamma correction on it, so that it's even in the dull room, it's actually looking a lot better now. So hope you appreciate that. I mean, you may not. You may have preferred to see me in complete darkness. Anyway, we're at a good point. So what I'm going to do is I'm going to commit this. Actually, no, I'm going to put it into a new branch because it's we had something working and now we're working on loading templates. Right. Initial implementation of loading in template data. Is read and written to the buffer. No manipulation of the icon data is performed, so indirected content won't be correct. Also, the fonts are not even considered. All right. I think I've missed a few files here because I've added some new files. Yeah, there we go. C/C and H. There we go. Commit, and add that to the commit we just did. Push. Okay, that's now pushed, and so should be available up here. Loading templates was pushed. Excellent. So if anyone wants to have a look at that and see where we're up to, they can. It is now time for a short break. Short branch, should I call it? Loading. Ooh, can't type. Now is where we're up to. Okay, 10-15 minute break, and then we'll come back. Okay, thanks for watching so far. Hope you'll be here when we come back. Bye. Hello, sorry that took a little while. I was unloading the dishwasher as well, not dishwasher, washing machine as well, which took a little bit longer. But we're back. So let us just go and have a look at where we're up to. What have we done so far? So far we've now got a routine that can basically copy a chunk of data, not that bit, this bit down here, copies a chunk of data into a buffer. I mean, realistically, I probably could have just done write bytes, all 88 bytes of it, and then whatever, but there are some manipulations you may wish to do at some point in the future, and let's try and keep this as sensible as possible. Just checking, I am not mute. This is good. I really want an on-air light that says I am actually playing, recording something, or it is not mute or whatever, because at the moment I'm missing the fact that I'm talking to nobody. Anyway, but at the moment I'm doing fine. Okay. So yeah, they've got this data that writes it, and it looks like, from what we've seen in here, if we scroll back, this is a dump of the memory. It looks like data. It looks like we've actually got something useful here. So that's very cool. It's not right, but it's cool, because each of these, the sections of icon data needs to be fixed up. If there is indirected data, we need to handle it as indirected data. So this routine that isn't implemented properly needs to be implemented properly. And if you were here earlier, you'd have seen this routine here, fix up icon, which does the handling for this. Because, oh my gosh, is it involved? It's not stupid, but it is a bit fun. So we're going to go and do this. And try and handle those errors. You'll notice in this Python code that I don't actually, I don't support fonts. Oh, that's interesting. Oh, that's something I'll need to fix up as well. We don't actually use the buffer functions that I mentioned. And the reason for that is because I created them after I did this. So all of this code that does this handling here is actually a little bit more involved than it needs to be. We can probably simplify this. So, but for now, let us see what we can actually get out of this, shall we? Okay. So fix up icon has some particular functions in it. Let's take a copy of it, and then what we can do is we can try and implement what we've got in the Python but in C, which shouldn't be all that hard. It shouldn't be. I mean, it probably will be because life is like that, but let us see what we can do, shall we? So this is the code we need to implement. I'm just going to make it a bit shorter by unindenting it a little bit. 2 unindents, I think is probably good enough. There we are. And then we can start putting this in here. So start out with the debug code. Processing icon flags. Oh dear, I'm gonna sneeze. Oh, excuse me. Sorry, couldn't get to the mute fast enough. But hopefully we're back again. Hopefully I won't be sneezing too much. There's a thing about if you stroke your ear, you can't sneeze. I'm unsure whether this is true. Let's have a see. Right. Off we go. Icon flags. Right, so this handling here is for... We can actually just copy the whole blooming line, can't we? We may as well do it the same way. Icon flags and that or that. So that's one check. And so this is saying, what are we saying here? That's what I wanted. We're saying if this is a sprite, if it's either text or sprite and it's indirected, we're doing this block of code. In fact, if I read the comment here, it would have told me exactly what I was doing. Yeah, fine. Now we don't need to decode anything because we've already got these in the blocks, but we can go and write it. We can say text offset equals the data we've got in icon data, and we need to actually use the right structures, don't we? So let's have a see what the structures look like. So in icon data, we've got loads of bits here. Just take a copy of it, and we can see it alongside. There we go. So we're definitely working on indirected text and text or sprite. So it's one of these three cases. Is that right? Yes, that's right. One of these three cases. So we may as well do it as indirect text to text. And what's the next? Let's press the wrong button. Indirect text validation offset is validation. And what's the other one? Length. Well, length is always length. So int length equals that one, and it's called size. I'll get that in 32T. There we go. Right. Ooh, I pressed the wrong button again. There we are. All right. So now we've pulled this data out here. Text is none, and that is none. So here we've got a check for this case. If icon flags is explicitly that value, don't need a slash on there. Right. I'll just copy this section. It's an indirected sprite, so it might have a sprite name, or it might be a sprite pointer. It's almost always going to be a sprite name, but we'll check nonetheless. That makes sense, yeah. If the length is 0, then we know it's a sprite pointer. We'll flag as an invalid text offset. Good. I'm with this. I'm understanding. Next bit. If the text offset is 0, then I need to include the template, the offsets for the indirected text. Oh yeah, there we go. That's making it different. Sorry, message. Nope. Okay, so I need to pass in a value that is the current indirect pointer in the file, so I can increment that. Unfortunately, that's going to be a pain to do. So what I'm going to do instead is I'm going to do something very similar to what we did in the Python code. In fact, am I going to make it very similar? Or am I going to do exactly the same? Let's have a look. So the data that we've got in the... Oh, I've lost it. Where's the data that's... Here we go, this thing. Template file pointer. Yeah, I don't think I need most of those, but template file pointer I do, template offset. So let's create a structure for this. So we'll call this typedef struct load template data. Load template data. This is going to be a structure that we just pass around that's got the bits we need in it. And honestly, it's going to be those things. Ooh, we could probably pass around the OT as well, couldn't we? There's no reason for it to not be stored in there, because then we don't have to handle anything else. Yeah. We literally just pass in the load template data t LTD. Load template data, that's fine. But the thing we were actually interested in was the indirect offset in the file. So let's just comment out the Python code. Yeah. Python code go bye-bye. There we go. Now we'll make this bit do the same thing. So this is LTD to buffwin. Icon data is the same. So that's actually everything done there. And then here, I want to copy this so we can populate it on this side down here. Create a load template data t LTD. And this needs to be initialized up here before we load the title data. I'll change this because we're actually doing it now. Fix up title data. LTD to dot .ot equals OT. LTD dot buffwin. LTD dot buffind equals buffind. LTD dot template offset. Oh, sorry, indirect offset. Sorry, that should be. Equals right. So we need. Oh, I need to know what this is going to be. So this is going to be the. So the current offset here, offset plus offset, that's stupid. No, offset plus read. Ugh, that means that the data we were pulling out was wrong. But at least we've got this now. This is getting better. So this is going to be the offset plus the number of icons that we've got. So win.icon, icon count times size of icon data, oh sorry, Wimp icon data. And the reason it's that is because if we look at the definition of the template, which is here, we can see that there's the window definition followed by the icon definitions, and that's where the indirected data starts after that. So there we go. Okay, so OT, buffwin, buffind, that's all the parameters that need to be passed in. Got too many brackets there. Fix me the something or other. Oh, come on, my brain's just gone dead. The font data will need passing in to. There we go. So we'll need to handle that. Okay. So with that done, I think if I now rebuild it, it should be okay. Or not. Oh, yeah, okay. So, yeah, we don't have these icon constants. And I don't think I've even defined these constants either. In fact, just replace that with nothing. And then it'll all be more correct. Now, I'm going to need to copy these. So here's my templates. I need to put these constants in here, don't I? So I'm going to need to find those. And they were in this one? No. This file here? Yeah, this file here. So it's icon text. There we go. This hasn't included them in a sensible order, has it? Maybe I should have sorted them. Even sorting them by name would have been helpful. In fact, sorting by name would be helpful. Let's do that. So go up there and then do... Oh, I've gone a bit far, haven't I? Because I just want the icon flags. Selection, you can't see this, it's on the other screen. Where's sort gone to? Sort lines. Bing! Much better. I'll actually be able to find things now. So we don't want all of these. We want text and sprite, indirected, and I think that's all of them. I don't think we actually need any of the others. Probably need font handle as well. So I will need that later, and I will need the anti-aliased flag. Copy that and put it here as well. So all of these, copy, can just go in here, and then I'll put them in a different order. So I want text at the front, just so we've got the numbers a bit better handled, and then 8 there. There we go. That looks all right. Oh, icon font handle shift. Didn't see it in there. Handle shift. It's down here. It's an anonymous one. That's fine. Okay, that can go in here as well. There we are. All right. So with that in mind, we go back over to the sources, and these constants should now be valid. There's no indirected text field. That should be a dot anyway there, not 2. It says no indirect text field. I thought I copied it out of it. Go back to the types again. Where's icon data gone? Icon data. Indirect ed text. Is that why? Yep, that's why. There we go. Excellent. Let's just tidy this up so it goes here. That's a bit tidy. Right. So now we can continue with where we're up to. So we've done all of this down to here. Next is text offset. So this is reading the indirected text string, and then the validation as well, and then we print out the message. So let's do that. And that's all inside here as well. If text offset is not equal to 0, then seek. Well, yeah, we know how to seek. That's templates underscore seek for LTD to OT, open template. And we want to go to the offset. The offset is I've forgotten. LTD to indirect offset, isn't it? There we go, indirect offset. And then we want to read a string. Now, reading a string means that we also want to increment the counter. So I need to pull in some data. Yeah, but what's the easiest thing to do? It's probably just to call fgetC a number of times on it, isn't it? What we'll do. Text. Ah, we haven't actually got a text. So if we look down here, we see that text is actually scoped just within this function. But I think, yeah, let's just scope it within here. So let's put a char star text equals I'm going to want to load this, aren't I? So do we actually want to copy the string straight into the indirect buffer? I can't copy it straight into the indirect buffer because the indirect buffer might not actually have any space. I could copy it into a temporary buffer, but then temporary buffer could be huge. Ah, but I know how long this string is going to be because it's got to be of length. Oh, but then I won't know it for the validation string, will I? Oh. That's frustrating. See, in Python, it was a lot easier because you just load it into memory and go, nah, fine, it doesn't matter. If it's 42 megabytes long, it's 42 megabytes long, we don't care. I mean, yeah, you're not going to have a string that's that long, but I created string buffers that are like 64K long before. And no, maybe 32K, I don't think I did it at 64K. But I've had them being very, very long previously. And I don't really want to be doing that. I definitely can't go and put it on the stack. So what do we do here? I'm trying to think. I caught my nail, it's annoying me. What I could do is have the string read as being read the string in chunks and see how big it is, and then use that just to load it straight into the buffer with a read bytes. So that could be done. I can read and cumulative write that just goes and writes it into the data. That would be possible. But then that's not especially nice, is it? See, the note that we saw earlier that mentioned about how the classic Wimp did it said that it loaded it all into memory and then manipulated it there. And that's, yeah, not unreasonable. But we're not doing that. I'm trying to keep the memory usage down so I don't want to be doing things that are a bit silly. I'm not sure. I'm not sure the right way to do it. Yeah, I definitely don't want to read it into memory. That's definitely the case. And the indirect buffer is going to be of length, because that's how big it's going to be. Yeah. Oh no, I didn't mean to do that. So I was going over here. So if we have a function that is templates copy indirect. So this is going to take an OT and at the current offset string indirect. So it's going to copy from the template buffer into buff_int, and as a string, and the maximum length it can be is going to be length. Yeah, okay. So now we'll implement that. So that's going to be templates string indirect. And this is a string. Copy a string from the templates file to the indirect buffer with length. OT is the template. buff_int points to the indirect buffer. Length, yeah, that was the other one. The size in the indirect buffer. Okay, and we're going to need to return an indication of the error. So if we get any off, we need to handle that. Is that the only thing we need to handle? I think so. So template error code. Template error T, isn't it? There it is, yeah. Okay, so this is an open template T start OT, a buffer data T, buff_int, and a length. Okay. So we've already done the seek, and we also want to return this as T error. There we go. So the easiest thing for us to do here is just to do while1 int c equals fgetC get a character if c equals eoff, turn t eoff. There we go, that's that bit handled. And then we want to write this data into the indirect buffer. So buffer data write. Ooh, do we have a function for writing a single byte? No, it's all about strings and like write bytes, write byte. Oh, we do. We have an update byte. Ooh, update byte. Huh. Because actually, Yeah, I'm going to do it as I write bytes. I could probably actually do a little bit of caching on this. Actually, no, I'm not. I'm not going to do it that way just because it's going to confuse me. So write bytes. We can improve this in the future. Let us just get it working first. There you go. Write 1 byte. Oh, if C is less than 32, if it's less than space, C equals 0. Make sure it's terminated. If C equals 0, return. Okay. Not return, no, break, because we know the length. Rote equals 0, rote equals 1. And we want rote is less than length. No. 1. If length just let me think. No. Whilst there is space in the buffer, continue writing it. There was an update byte thing I could do, wasn't there? Where's update byte gone? At the offset. Oh, I want to have to update an offset minus. Just go back 1 byte. Oh, bother. I just want to write a 0 there. I want to write a terminator to the last byte. There we go. And then we just want to pad it. Oh. If rote is not equal to length, there was a write bytes padded or something, wasn't there? Write bytes padded there. Oops, no, not that. There, please. Write bytes padded. Yeah, that's right. Yeah, so we write to buffins null 0, but the padding length is length minus rote. So that'll now pad it up to the end of the buffer. And if everything was okay, we return there. So I think that should do the job. It's a little bit more complicated than I'd intended, but it's not terrible. I need to move this out because this is actually still in the middle of my other function. So let's go and move this out. So the thing that's not necessarily obvious about this is the indirected string table can contain more data than you're expecting. The reason for that is because it's got, oh, it doesn't want to go there, does it? It wants to go a bit higher. Let's find identifier, close, because this is a file manipulation code, so I'll put it all with the file manipulation stuff up here. No, I probably don't want it there. I do want it down here, don't I? Oh, except just put it somewhere. There we go, fine. I'm happy with it now. I am happy. Honest. Right. So that'll now write out that data. Template error, if t is not equal to t okay, return t error. There we go. So if there's an error, we'll report it. Now there's this one, which is where, oh, hang on. Oh, no, that's already updated the, oh, the validation offset hasn't been updated, has it? Oh, poo. No, I'm going to have to, I should probably just pass in LTD and length. And now it's a function that needs that LTD structure. Let's copy it back from where I was put it. And put it after the LTD one. Yeah, so that's fine. This is where using the Python structures made things easy in Python, but it means that I've got to implement things in a different way in the C code because I don't have those structures to be able to just transiently pull data out and things. It's not the end of the world either way. So yep, we're doing that. Instead of passing this in, we want to pass in the LTD, which is the load template data structure. And the length still wants to be there. LTD to OT. Oh no, that's wrong as well, because that should be LTD to buff ind. LTD to buff ind. Again, LTD to buff ind. Yeah. We also want to do LTD to indirect offset plus equals 1 because we're moving along further in the indirect buffer, in the indirect data in the file. So that was why that was useful. Okay. So that's not too terrible. We just need to use it now. Oh, I did use it here. That's all right. And we've got the same code here for this bit, for the validation code. Seek to the indirect offset. In fact, that seek could probably actually take place inside the string indirect, because we're already reading from the string indirect buffer. So that just saves us having to do it every time. That's nicer. And then if the indirect offset is not zero, read the length. Ah, you see, this time we don't know what the length's going to be. Oh, this is one that just should be the same length as what's present. That's irritating. -1. -1 indicates as long as the string is. Oh, except I'm also not returning what the pointer is to that string, am I? Oh, that's going straight into text, isn't it? That's where the text string is. Yeah, that's okay. I like that. Yeah, and some text. Actually, no, that's validation there, isn't it? That's the validation string. All right. Yeah, there's some brackets missing here and things. Turn the Python into C code. And then we can just do some dprintfs. Oh, there, that's what I wanted. Indirect string of length is, I can't do a %R, %S. Oh, dprintf. And that's not the way you write it out in C either. Length, and this is text. Okay, and we do the same with the validation here. Okay, too many brackets there and not a semicolon, and I think that looks okay. Let's just put some braces around that just so I feel a bit more comfortable. Ooh, and I need braces around this one because it was doing multiple things. Okay. And now we need to implement the section of code that I was doing for the returning the pointer to it. Text P. So char star text P. Text equals LTD to buff_int buffer data underscore address. I believe it's address is what I want. Not template, sorry, buffer data address. can't. Address. Convert an offset in the buffer to an address in memory. Yeah, okay, so that's cur, and then say 0 and seek cur. Oh no, not it's relative. Yeah, 0 and then true. That one there, thank you. And the 0, true. Okay, so that'll give it a text. And then at the end, if we didn't fail, text p equals text. Otherwise, we'll write it as null. Actually, probably the best thing is not to write it as null there, but to write it as null at the top. So that if we exit at any time, like here, where we exit, it would still end up being null, and that would be then safe. Okay. Yeah, good. Good. I think that should do the job. See how well that compiles, if at all. Not very well. Implicit cast of is that because it's a uint 8t? Probably. Wrong number of parameters to template seek. Yep, because that should be seek set. Implicit cast of pointer to non-equal pointer. Oh yeah, because that should be to file handle. Implicit cast of pointer to non-equal pointer. That's because it's no longer, it's uint 8t. Yeah, I should do it as a uint 8t there, I suppose. My decision to use uint 8t's seems to be biting me a little here. I have to put this one up here, aren't I? Might as well have it as a global. Let's build it again. Implicit cast of point, yeah, pointer to non-equal pointer, because both of these have got to be changed to be 8t's. I'm not sure this is the right choice, or I'm not sure that it's the wrong choice either. So, differing pointer types. Oh, which has problems here when you try and do this sort of thing. Oops, that should have been a colon there. Right. Still not working. What? Oh, I changed all of this, didn't I? So I'm now passing in the LTD. So ampersand LTD. Load template data. There we go. In fact, load. No, not all that. Sorry. Just the beginning part is the LTD. There, like that. And the same goes for the other one down here. Doop. Size declare but not used, but we built it. Excellent. So there's our run command. Those strings look fruity, don't they? They're not quite right. Maybe it's not working. It's kind of interesting. I wonder why that is. Oh, it's clearly because I've got something wrong. But what? I'm assuming that I've actually got the offset in the file wrong. That's where we're going screwy on this. So that's the icon. In fact, I can just have a quick look. Memory ICO38. Probably don't want to do it that way. And we haven't actually updated any of the data here, so it's not going to have any actual useful information in it, unfortunately. Indirect buffer there needed 198 bytes, so BC38, BC38. Yeah, that looks like template information rather than. Yeah, that wasn't what I typed. I typed CO38 rather than BC. Ah, that's why. It says this one here. That's just got zeros in it. Ooh. Ooh, interesting. Means we haven't written any data into the indirect area at all, which is odd. Template string indirect, and then we return them. Into validation, into the text. Let's just put a null in there, because then it would be safer. It's not particularly significant, but safer nonetheless. We get the address that we are writing to. Indirect offset +1. Did we actually initialize indirect offset? We did, didn't we? Indirect offset is there. Okay, so let's print out indirect offset equals %i. Actually, put it in hex, because then I can go and pass it to some other routines. LTD.indirect offset. There we go. Build that. Exit this. Actually, I didn't need to exit it, did I? Could have just run it again. No matter. Right. So the important thing here is indirect offset F0. Okay. It thinks that the indirect text is at F0. That doesn't feel right to me, but I'm not sure. But if we dump, oh, hang on, test data dot templates dot, oh, what was it called? Info. Right. If we have a look at FO, oh yeah, the data at FO is not indirect data. It's way down here. Way down here. That's very strange, isn't it? Offset plus win.icon count. I'm just going to put brackets around that purely for my own sanity. I know that that is correct, but I'm just going to do it anyway. Indirect offset there. No, not size of icon data, size of icon. Because icon data is just the texty bit at the end, not the whole chunk of the data. So if we now run that again, af32.wimp templates. Oh, look at this. Look at this. We have strings, indirect text, empty, validation program. That's not right, is it? Text 40. Well, it does. Really, have I got these round back to front? Surely. No, I can't have done. Oh, maybe I have. That would be weird, wouldn't it? Because it means... what? Indirect offset is at 1A4. And I've got a dump of the file here, so 1A4, have a look at that. 1A4 is here, which starts with about this program. Program. So it looks like we've definitely got something inconsistent here. And just to be sure, when we go back up here into this text offset, we definitely do text first. Let's put a little bit of debug in here. Why not? Reading indirect string from offset. No, just X, don't we? Like that. Comma LTD to indirect offset. There we are. Build. Yeah, there's going to be a lot of debug coming out of this. That's fine. Still built okay. Reading indirect string from A4, indirect string from B7. That looks correct to me. It looks like the string that's coming out is wrong. Okay, so where did our buffer, this BCEO, memory 0 BCEO, I need to fix that bug, that's silly. Indirect buffer's got nothing, no data in it. Why have we got no data in it? Because we printed out some things, surely. Minus 40 plus 80. Nothing there, what? Very confused. We're adding to the indirect offset, we're adding to the buffer ins, we're writing the bytes that are padded, and then we're updating the text pointer. to address build run BCFO BDO3 BDO2. What? That went backwards. Whoa, 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 whoa. Why do we go backwards? Backwards is bad. Length minus rote. That's definitely positive, or ought to be positive. BCFO. BCFO. Oh. 0 BCFO. Still empty. But that's going backwards. Padding by %I bytes. I mean, it's always possible that I've got this wrong and I've actually... Is the indirect data stored earlier than the window definition in the file? No, it always comes immediately after the window definition. It always comes immediately after it. If we look over here, we can see this is the actual data format, so the data is always there, which means that it should never be negative. Yeah, that's a good point. It should never be negative or... Oh, hang on. What are the offsets? Are the offsets relative to the file, or are they relative to the... Hang on, I'm being confused now. I've been assuming that I'm copying just from the indirect data, but actually it's not. It says any pointers to indirect or offsets from the start of the current entry. And I've just been accumulating it and moving through the file. Ah, this is all wrong. This is just wrong, wrong, wrong. Yeah, I'm just writing. I've got myself confused on this. I'd assumed that every indirect entry was just one after the other, and we had to just step through them all. But that's not correct. It's offsets from the start of the entry. But even still, I've not written the data properly. Right, let's start again. So this is base offset, we'll call it. That's where the indirect data lives. Except we don't even add that. We just want offset. We don't need to know any of the others. Yeah, so indirect offset should now become base offset. And we should pass in the ind offset from window base set. Is there? Next buffer address is correct. Seek to LTD base offset plus ind offset. I suspect this was probably really obvious in the Python code. It also means that I don't need to do that and to keep them incremented. It's just a misunderstanding on my part about how they're written, which was stupid. Doesn't explain why they're not being written into the file. That's a separate problem. Into the memory rather, but it does at least give me something to go on here. So what I need to do here is text offset there and validation offset here. It's all very efficient if you're thinking like an assembler programmer, but I'm clearly not thinking quite that way. I'm not sure this is right. There's no indirect offset. I missed one. 484 indirect offset. So this is a base offset now. There, okay. Padding by -2 bytes. That's not good. Padding by 376 bytes. No, 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 no. That's very wrong. I have a feeling I've got some parameters around the wrong way. Not that way, this way. Offset, length, oh yeah, I've put them around the wrong way. And -1, I didn't actually implement that. I don't need brackets around that one. Or still got padding of -2 bytes there. Oh, yeah, that's because yeah, that's why that should be. We don't pad it in that case. Okay, let's build it and try it again. Yeah, I'm still at it. Still not finished on this bit. I'll be getting there. Right. Still not got the right blooming strings. Reading indirect string from 1FC and then indirect from 83. So let's see what the string is at 1FC, shall we? No, dump. Where's my dump command line? It's up one up here somewhere. So what was the address? Reading index string from 1FC and then 83. 1FC is in the middle of this string. That's not correct. And going any further than that, the file doesn't go any further. And I know why that is. Oh no, I know why that is. That's because I'm stupid. In here, I increment this by the size of red. I shouldn't be doing that because we want the base of the template of the window. All based on my misunderstanding of how indirected icon data lived. I mean, we're still not working. 1A4 and then 2B. 2B also looks like rubbish to me. Reading indirect string from offset. Reading indirect string from offset, base offset plus offset. I don't see how that can be offset 2B. That seems wrong because 2B would be inside the template data itself. I'm not sure I can see it in here. When I look in here though, window base offset is 2C. So how can that be offset 2B? It can't. Because that's -1. Unless -1 also means not valid. I'm not sure. It's possible I may have to leave this till next week, although I'm not doing one next week. I'm not doing a session next week because I'm preparing for my presentation. Offset length, offset length. Padding by -121 bytes. What? No, this is all rubbish. I am going to have to come back to this. There is definitely something going wrong. Dave suggested 2B and not 2B. Not sure what that means. Well, I've done anything with that. Not to be. Yeah, I'm getting you now, sorry. Stupid me. Right, okay. I'm going to call this as a bit of a write-off for today. It's all right, Dave. It's just my brain's not quite with it enough today. It's quite all right. Right. Status. Oh, no. Implement broken implementation of the icon data fix-up. The icon data fix-up is implemented but isn't correct. And a new, very off, and a new pair of eyes might help. Anybody wanting to have a play with it, please have a look and have a see where I've screwed up, because I'm sure it's obvious if you spend some time with it, but I am clearly struggling. Right, it's definitely not up to do with that being married. Thank you very much. We both appreciate it, I think. So what have we managed to achieve today? Started writing some of the load code, seems to be kind of getting there, but clearly we've got a bunch of problems with the icon offsets that I thought was going to be easier to do than it has been. So we'll come back to that. There will be no session next week. I'm preparing for my much larger presentation, which I haven't really got very much done for yet, so I need to really get that done this week. Otherwise it'll be all off the cuff on Monday, which you really don't want. It'll be a whole mess if I do that. Yeah, so I hope you have a good weekend, what's left of it. We'll leave this here. If you want to have a look at the code and point out where I've gone wrong, because I'm sure there's something dumb in this. I would appreciate it, but don't feel you have to. Thank you very much, and we'll see you not next week, but the week after, I think. All right. Bye.